physics and the last presentation. Okay, let's do it. Our talk, my talk will be on points inflation based on this paper, points inflation in f of t cosmology. First, we have introduction about f of t theory. I will say it quickly. And then we talk about scale factor, a of t, and constructing our model in f of t theory. The problem. The problem in cosmology nowadays are dark matter and dark energy, and some solutions for these problems are cosmological constants and using a teleparallelism space instead of Riemann space. And f of r series, this is the action of f of r theory, and the field equation. Now we talk about f of t series. It's applying for the lead time acceleration. The formula of the series is the element of the reheating space and the contortion and torsion tensors, and finally the torsion scale. Like f of r, this is the action for f of t field and the field equation. The properties of f of t series is based on it produces the second order dynamical equation, and it contains more degree of freedom than GR. Okay, the scale factor a of t, we have an introduction for that section. F of t gravity allows two unknowns a of t and f of t. We have two possible ways to describe our inverse. The first one is introducing a specific f of t and solution for and solving for the scale vector, or introducing a scale factor and solving for f of t. Our paper is for the second way. Now we describe the dynamical behavior for FR model by constructing its H.H phase space diagram. This is a diagram for FR model. Now the shaded area are described a acceleration region, and this area and this describe the acceleration one. There is no transition from an acceleration to acceleration in the model. Okay, and define the scale factor. First in GR we have to transition from an accelerated to accelerated expansion. We have to change omega from this value to this value. This is manual, but in f of t we can choose a modified scale factor to do this. Okay, we need the scale factor to construct an H.H phase space for this model to able to transition from accelerated to accelerated to accelerated. Okay, this is our modified scale factor. The first part is FR scale factor, and the second part is a correction scale factor. Okay, if you fix Ti and Ak in the scale factor, we have two values for alpha, positive 1 and negative 1. For the positive value of alpha, we have a graceful exit inflation model. As T equal T tends to 0, the scale factor also tends to 0, and the density tends to infinity, which is a Big Bang. In this part, T less than the value for alpha, which describe pre-inflation. When the value of alpha equal the value of T, we have a time inflation, and then when alpha, when T greater than alpha, we have a graceful exit. Okay, for the value, for the negative value for alpha, we have a points model. We start with added T tends to 0, we have effect scale factor from a contraction to expansion, which describe the points in inflation. Okay, it's H dot H phase space for this modified scale factor. Okay, we construct H dot H phase space to examine if this model able to transition from a contraction to expansion at a finite time. For the scale factor, we have H dot in this form, and this is the H dot H phase space for our modified scale factor. And showing we can transition from a contraction to expansion area at the point time t, which is a finite time, and transition from a decelerated, also from an decelerated area to from accelerated area to decelerated area. Okay, now we can start the model in f of t theory, f of t form. If you apply f of t equation for this tetrad and substitution for the torsion scalar in the equation, we have a density and pressure as a function of time in these two forms, and we can find the form of f of t form. The last thing is application for this model and normalization of the inverse. We can use it in reheating in points inverse and unify inflation and slow and energy condition. Thank you.
Yeah, we have another time for questions. Okay.
So I missed something. Can you conclude anything about what the function of the torsion is?
What the function is?
Yeah, f of t. I mean, what is it? Exponential? Is it a power? Is it a...
It's exponential times f of the...
It's an exponential function of the torsion.
Yeah.
So you have no general coordinate invariance on large scale.
Sorry?
So where does the general coordinate invariance break down? Because it must. The torsion, if you linear in the torsion, you could have an equivalence to GR, and you could have general coordinate invariance. As soon as it becomes a nonlinear function of a torsion, you've thrown out general coordinate invariance somewhere. I'm just trying to establish where you're doing it, large scale, small scales, or where.
I think it's little scales. She just uses a taper, then she works in the tetrad, so it's already broken from the very first, from the very beginning.
Sure, I'm just trying to establish is that does you want to do this for inflation, then you need, in a sense, one F. If you want energy, you need another F. Right? But you can't do both. So you can't say fit everything together as some of the other models.
Any other question? If there are no other questions for time, let's thank you.